Hello friends, welcome to our channel Ritz Info Hub. If any of you are new to our channel, please subscribe the channel by clicking on the red colored subscribe button and click on bell button also to receive the notifications. And if you like the video, please don't forget to click on the like button guys and try to share to your friends as well. Yes, welcome to our channel guys, and in this session let us discuss one question from Newton's laws of motion belongs to rocket propulsion. The question is this is 1 second. Let me. Yep. Okay. Yes. So the question is the first and second stage of a two-stage rocket separately weigh 100 kg and 10 kg and contain 80 kg and 90 kg of fuel in those stages respectively. If the exhaust velocity of the gases is 2 kilometers per second, then velocity of the rocket after second stage is nearly, okay, it is given that log 5 base 10 is 0.6990. Neglect gravity. These conditions you have to make use while doing it, right? So it is given that the total mass of the rocket, that is the masses of the two stages and the fuels together, is 100 plus 10 plus 800 plus 90, total is 1000 kg. And when initially the rocket is at rest, means even though the fuel burned, the gases comes out with respect to the rocket, the velocity with which the fuel comes out is, this is the velocity with which, but the rocket initially will be at rest. And when the fuel comes out, then after the exhaustion of the first stage, okay, that means the rocket velocity after exhaustion of the first stage, that is after complete combustion of the fuel in the first stage, the velocity obtained is given by v is equal to u into log m naught by m, where u is uh, uh, exhaust velocity of the gases, where u is the exhaust velocity of the gases, and m naught is the total mass, and m is mass of the rocket at that instant when after exhaustion of the first stage, means after a complete combustion of the fuel in the first stage, the total mass will be initial mass is at 1000 kg. When the fuel in the first stage has burned off, that mass disappears, so the total mass of the total rocket plus mass of the fuel in the first stage will give you the mass at that instant, so that will be taken as 200 kg. So velocity obtained is v is equal to u, exhaust velocity of gases is 2 to log m naught 1000 by m is 200, or simplifying this we get to log 5 base e. But in the question, log 5 base 10 is given here. So to convert this into log 5 base 10, you have to multiply unless in any logarithmic value with the base e. To convert into base 10, you have to multiply with 2.303. Try to remember this, guys. This is a conversion factor, you can say. To convert log of any value base e to log of that value base 10, you have to multiply with 2.303. So now to convert this into log 5 base 10, you have multiplied with this, and then it becomes log 5 base e becomes log 5 base 10, because this value is given in the question, take it. And if after multiplying, we'll get this log, sorry, 3.218. Actually, it's not 281, it is 2218. Yes, this is, let me, yes, let me take this here. This will be, this is a 218, not 281. Try to make a correction of this. This 3.218. Next, the velocity, final velocity of the rocket after exhaustion of second stage also, if you want, here you have to take once the first stage burn, the fuel in the first stage burns off, for the second stage to start working, you can say the entire first stage should detaches, means the mass of the fuel anyway burned off, even the mass of the first stage also should detaches. Then the final velocity will be given, final velocity after burning of the second stage will be the velocity with this is the second stage as a starter. Second stage is starting with the velocity which is given by the first stage, that you can take it as a 3.218 meter per second. And now the total mass of this rocket is mass of the second stage plus the fuel in that, that is 100 kg. So once the second stage fuel burns off, the mass at that instant will be 10 kg. At that time, what is the final velocity you want to find? So v is equal to u plus u naught. Here u is initial velocity of the second stage. U naught will be taken as the exhaust velocity of the gases and log m naught by m. So 3.218 plus 2 into log 100 by 10 base e it is. So on simplifying it becomes log 10 base 10. So log 10 base e to to multiply it, you have to multiply to make it log 10 base 10, you have to multiply with 2.301. So 2.303 into log 10 base 10 it becomes, but log 10 base 10 will be equal to 1 log x base x or any of the logarithmic value, logarithmic functions with the same base will be equal to 1. So we can say even log 2 base 2, log 10 base 10, like this kind of binary values also. If for example I'm telling, okay, log m base n will be equal to 1. In that way, log 10 base 10 equal to 1 here. So this on simplification, this gives you v is equal to 7.82 kilometer per second. This is the final velocity obtained by the rocket. I hope it is clear for you guys. So if you like it, if you like the explanation, please click on the like button and don't forget to subscribe the channel, guys. Yes, take care everyone, and Jai Hind. I'm signing off.